Hello? Hello. Thank you. Who's been using IdentityServer in the past? Okay. Version 3 or version 4? 3? 4? Couple of people? Okay. Why are you here? So this talk is mostly useful for people, that have been using 3 and now want to go to 4 and to see like what's the delta between the versions. But obviously, if you haven't used it at all, you'll still get something out of it by me trying to write code on this lovely table here. So, we created IdentityServer4, or well, I don't know, 2.5, 3 years ago to solve a problem, right? So it's not like it didn't happen because we wanted to sell something. It happened because we wanted to solve a problem. And the problem was that basically none of the commercial offerings, identity offerings, are really good enough for today's scenarios. Yeah, so they might be okay if you're starting on a complete greenfield scenario and if you are adapting your business to how their stuff works. But if you want to do the way you want to do it and just have a framework that works the way you want it, or if you're having more complicated scenarios like migration and all these things, then customers just came to me and said, like, we evaluated all of these products and they don't work for us. Yeah, so that's why Brock and I started writing this framework for identity. So yeah, it's not a server that comes with an install exe and you just walk through a wizard and then you're done, because that's what all the others do. Yeah, you get a framework. It's for developers. IdentityServer is only useful if you're willing to write code against it. Okay, so that was our intention back. Actually, the very first version was in 2009, but the whole framework thing started, I guess, 3 years ago or so, where we actually hit a brick wall as well with our all-in-the-box solution style, which realized, wow, there are so many other scenarios out there which you can't cover with a turnkey style solution. Yeah? So, many people used IdentityServer4. It was built on top of Katana, which was the predecessor to ASP.NET Core. Katana had a couple of issues. Mostly lack of features that we actually needed, things like DI and logging and actually a UI framework and so on. So we had to work around all of these things. We are not proud that we wrote our own view engine, believe me. Nobody wants to do that, and that we had to implement our own anti-forgery cookies and protection and all these things. So. But yeah, that's the way it was, and people were happy for the most parts with that. Now, when the whole ASP.NET Core thing started, Microsoft, the ASP.NET team came to us and said, like, you know what? We have these OAuth authorization server middleware thing, and we gave a lot of vocal feedback that this is not really good what they're doing, and they knew that, and they said, yeah, you are right, I mean, we should stay with our core competence and just build the web framework and let security to the professionals, as Philip once said to me. So they said, okay, you know what? For ASP.NET Core, we're going to focus on just consuming tokens, right? So we're going to build all the middleware that you can connect your MVC applications to a token service to consume the tokens. We're going to build the middleware for your JSON, for your web APIs to consume tokens, but we are not going to build anything that will produce tokens. So they said, like, are you guys willing to fill that gap with IdentityServer porting it to ASP.NET Core? And by the time, I was young and I needed the money, I said, yeah, let's do that, sounds good, And then there was this whole long period of ASP.NET Core, having drama every day, and, nightly builds, RCs, which were pre-alpha status, and RTMs, which were RCs, and keeping up with that was tough, right? So a year later, I have gray hair. I didn't have that a year before, and we finally released it. So in the end, we are happy with the end result, but it was a long road, and that was mostly the .NET Core road, which was long. And we and we had to basically keep up with that. So what this talk really is about is what has changed in between 3 and 4, which is also about what is new in ASP.NET Core, which allowed us to make these changes. So we deleted a lot of code, and that's a good thing. Yeah? Why? Because that code was moved into the base framework. So the first thing that is actually new is we have a website, finally. A cool I/O website for the cool open source project. That is basically your starting point into everything IdentityServer4 related. Yeah, so you can get to the GitHub repo from here. We have documentation now. Well, we had it before, but I think it's better than the one we had before. We do training on a regular basis. I just did a training yesterday and the day before, but there's more, for example, in Oslo again. People weren't aware that we are actually doing consulting, so just if you're asking yourself, writing open source software doesn't pay the bills, right? Because it's, for many people, open source means free software, right? So we are actually doing consulting most of the time to be having the luxury of doing open source on the side. Yeah? What is actually new is we have production support for, with SLAs. So many people said, yeah, we would like to use IdentityServer, but our admins are nervous. They want to have a production support plan where they can call someone if something goes wrong. And we have that now both for the States and for Europe. OK, let's go to the source code. So here's our organization, in case you haven't seen it. It's basically now, it's all about IdentityServer. We have 4 and 3. 3 is still being maintained, right? So we are not abandoning it completely. We still do bug fixes. If we think there's a really important feature missing, we're going to backport that. But obviously, being just a 2-man team, right, and a couple of contributors, we cannot do full feature work on both versions, so all of our investments are going into 4 right now. Yeah? We think 4 is the best token service we've ever written. We added many nice features. Some of them I'll show you. And yeah, I would recommend everyone who now makes a decision to do 3 or 4, just use 4. Yeah? We are happy with that. So in fact, a very common scenario we have is that people have an existing IdentityServer 3 and then started writing applications using ASP.NET Core and MVC Core with 3, which is totally fine, right? I mean, it's just a protocol implementation, and it doesn't matter which framework you're using. But now, since 4 is done, they want to get rid of the Katana stuff and move even IdentityServer to ASP.NET Core. So that is kind of like the scenario I'm covering here. So we have two little, we have an API, we have a client which simulates like a server-to-server style communication, and we have an MVC client, and they are all working with IdentityServer 3. So my plan is now to just migrate that configuration from 3 to 4 and just leave the applications unchanged, right? And just prove that this is how it works, okay? So just to see what we have here, yeah? So we have an API host, using MVC. So let's run that. And this API host is just echoing back the claims of the user. We have a console client. So what is the console client doing? Again, the console client should simulate a server-to-server style communication. So, it goes to the discovery endpoint, it finds out where the token endpoint is, and then it requests a token from the token endpoint, and once this is done, it will call an API. Okay? Pretty simple. So when I run that, it works, right? We have a token, we call the API just echoes back the claims, all is good. And here's our IdentityServer running in the background. We have an MVC client. Yeah, again, pretty standard MVC. MVC core, right? We have the OpenID Connect middleware from Microsoft. So, you point to your authority, you pass in the client ID and the secret, you select your scopes, and so on and so forth. Yeah, so when I run that and click the secure link, it will trigger the authentication handshake. We end up on IdentityServer 3. Here we support both local logins and something, external, Google in that case, but could be anything else. So I'm logging in, I'm logged in to my website, and I can call now an API on behalf of the currently logged on user. Okay, so that's the scenario. So let's have a look at how that looks like. Okay, so in IdentityServer4, you used the Katana hosting APIs, either in IIS or in self-host. So basically, you configured the base address, you called webapp.start, passed in your startup class, and then this thing started running. One little interesting detail here is Katana didn't have built-in logging, right? So there was no logging infrastructure in Katana. So as a library developer, you had a hard time. What are you doing, right? I mean, you don't want to use, I don't know, log4net or nlog or serilog or whatever, and then force everyone else that uses your library to use the same logging library. Yeah? So we're using a library which is an abstraction over logging, right? Because the world needs more abstractions. And that's called liblog, from a guy called Damien Hickey. And he does some very tricky things, like basically he gives you a general purpose logging API, and at runtime he pokes around in your app domain to find out which logging framework is being used, and then we'll figure out, oh, they're using serilog. So now let's just dynamically invoke serilog logging on the fly, right? And if he would use nlog, he would use nlog and log4net and so on and so forth, yeah? Many people were confused by this level of magic. They're like, how do I configure logging with IdentityServer? I said, you don't. just do it. Yeah, it'll work auto-magically. Yeah? And that was a really good solution, and it worked quite well. So basically what that means is that with free, you configured logging at the hosting level, and then it was being picked up. The startup class in Katana, looks like this, typically. You have a configuration method with an iapp builder. Then the next thing we needed to do, because it wasn't built into Katana, was dependency injection, right? So we needed a way to give you a configurable container where you could put in your own services so you could modify the behavior of IdentityServer. So again, nothing was built into Katana, so we picked the favorite DI container by the time, which was AutoFac, and then built our own abstraction around it, which is called the IdentityServer Service Factory, right? And the purpose of that was that you could plug in your own custom implementation, for example, like where are your clients stored, where are your scopes stored, and where are your users stored, right? And then this would internally be turned into an AutoFac container, and that would hang off the Katana pipeline. And then the other thing that was the prevalent style in Katana is that now you had the middleware, and the middleware had like an options object. Yeah? And the options object configured every aspect of that middleware. Yeah? So, here's your site name, your signing certificate, then you pass in the factory, which is the DI container, and then whatever other configuration things you have to do. Okay? So that was the style in Katana, and now let's see how that style has changed for ASP.NET Core. So in ASP.NET Core, let's start by adding the NuGet package, IdentityServer4. We have this nice project JSON file, which will be gone in 2 weeks. So enjoy it while it's there, because then you're gonna continue starting to think in terms of item groups and property groups in XML files. Okay, so once we have that, you see now, first of all, the logging. Yeah, we are still using serilog as our preferred logger, but this time it's different. In ASP.NET Core, there's this the startup class has dependency injection even in the startup class itself. So when they new up the startup class, which is actually done by this piece of code here, the web host builder, which you pass in the type that implements your startup code, they call the constructor, and I think you already get like 14 dependencies, like the Logger factory, the hosting environment, so you can know if you are in dev or staging or whatever. And a typical pattern is actually not the pattern that is used by Microsoft, but my preferred pattern is that you set up all the logging in the constructor, and then it's available from very, very early. Okay? Same idea, we new up Serilog, but this time we just say on the Logger factory, add Serilog, and then we're using the built-in logging facilities of ASP.NET Core. So, what else do we need to do? To enable the first scenario is we need to add the IdentityServer middleware. Okay? So you see that there are no options anymore, because that is not how it typically works anymore in ASP.NET Core. The idea is that if you want to configure middleware, you're typically using the DI container to provide the right services for that middleware. So we have a thing called services.add IdentityServer, which now puts up all of our dependencies into DI. Okay? Now we need to do a little bit more here. So that the very first thing we probably should do is we should configure key material to sign the tokens that get produced by IdentityServer. And again, this is all done by wiring up a service into DI that has the key material, right? So we have this new thing called add signing credential. And you can see now we can use raw RSA keys here. You can pass in any signing credential type from the identity model library. You can pass in an X509 certificate, or you can pass in just the name of the cert that lives in your certificate store. Okay? Another thing that we added because of feedback is, people said like, yeah, in my company, I am not allowed to create my own X509 certificate, so I have to wait for the admin to give me one, blah, 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 and he's very slow, or he's busy with other really important things like creating AD groups or something, yeah? So we have this new thing called add temporary signing credential. And what this does is, at startup time, we just create a random RSA key pair, so you have something to work with, right? And, and then when you have the real key material from whoever approves that, you can just switch back to the normal add signing credential. Yeah, don't use that in production. You won't have fun with that. Yeah? Yeah. Okay. So now let's have a look at the configuration we had in IdentityServer4. So let's go back to our config file here. So one thing we needed to define in IdentityServer4 were so-called scopes. Okay, so scopes are the resources in your system that clients want to access, right? So whenever I explained the term scopes to someone, I said, a scope is like a resource. Yeah. There are two types of scopes. Yeah? One are more like the identity-related scopes, like first name, last name, and there are the API scopes, yeah, like APIs you want to call. And most people typically understood what a client is and what a user is, but scopes they struggled with. Yeah? And the more and more I started explaining that, I realized I always say a scope is like a resource. So we thought, you know what? Let's just rename that class to resource in IdentityServer4. Yeah? And you don't have to explain it anymore. So you see we had two types of scopes. One was called an identity scope, one was called an API, a resource scope, and one of them modeled an API, one modeled more like identity data. So what we now have in 4 are two classes, identity resource and API resource, just to make it really clear what you are modeling here. Yeah? So let's do this. Let's add a class called config and do a public static IEnumerable API resource get APIs. Okay, new API resource. And in the easiest sense, yeah, you say like, okay, I have an API, it's called, I don't know, whatever, yeah, API 1, yeah, or my calendar API, yeah. That's all you need to do. sorry, not this one, but this one, yeah, to just register an API with IdentityServer. And now we can reason about this API, and you can assign clients to this API, who is allowed to talk to the API, and so on. But there are more options here. If this API will ever be used on a consent screen, you can give it a display name, you know, my cool API number 1. And just to model the 3 most common things, if you want to define that whenever a client asks for an API number 1, the token should contain these claims about the user, you can just put the claim types here now. Maybe you need, like, I don't know, the location of the user, yeah? I mean, actually, we could do that. So that is an important thing for your API, and that's how you can model that. Okay. There are more options. And what this does under the covers, and that's it basically creates an API with exactly one scope, and the name of the API and the scope are the same. Okay? If you have more complex things, like you want to create an API, but you want to subdivide that into multiple scopes, like maybe a read scope and a write scope, or a read only, or something like that, you could do something like start with this, give this a name, API. That's the complex API. Yeah. It has a display name, complex API. It has user claims, right? So you could set, like, whenever you ask for this API, put these claims into the token. But now what you can also do is you can have a list of scopes here, like this, and then say new scope, complex API, read or full access, for example, yeah. And then could have user claims here. So what that means is, let's say you're just calling, you call the complex API, you will get the standard claims. If you're calling the full access scope, you get, in addition, the claims that you define per scope. Yeah? So you can model pretty complex things here. Yeah? So we think that that's an improvement over the old approach, where everything was just a scope, and we, by being limited to object orientation, we had to share the properties between the scope types that didn't really belong to each other. Okay? So that's how you model APIs. Now, the next thing we're going to model are clients. So actually, clients haven't changed that much. So let's just go to here and just copy that over. Like this. So a client is still a client. It has a client ID. It has a client display name, right? It still has a client secret. We changed that internally a little bit to make that nicer. So you can now use this style of setting up that in memory. Same here. API 1. I probably should call it API, right? To be compatible with the client. So what have we changed here? As you can see, the flow doesn't exist anymore. Yeah, so flow is a term from the spec, and it describes how a client talks to a token service to get tokens. And there were, there's the client credential flow, which is for server-to-server style, but there's also the hybrid flow and the implicit flow and so on. And when we implemented IdentityServer in the first place, we were aware that certain flows are incompatible. Okay, so for example, if you would configure a client to use both implicit flow and authorization code flow, and authorization code flow is the more secure one because it demands an authenticated back-channel communication, then a malicious user could just downgrade from code flow down to implicit flow just by changing a parameter in the protocol. right? So that wouldn't make sense to allow both flows for the same client because you are not getting what you're expecting you're getting, okay? So we thought, play it safe and only allow one flow per client, yeah? But then then we learned by, just by using that in practice that there are indeed certain situations where multiple flows are useful, yeah? Like for example, let's say you want to do interactive using implicit flow, but have a back-channel server-to-server style with client credentials. This kind of forced you to write to register 2 clients in the past, yeah, which wasn't that nice. So in the new style, we went back to the original term in the spec called a grant type. You see, it's plural now, so we support multiple grant types. We have a grant types class, which models the most common combinations, right? Like code and client credentials, or hybrid and client credentials. And if you want to be completely free form, you can use the list one and just pass in the grant types yourself. But we're still doing validation at creation time, so to make sure that you are not using the vulnerable combinations. Okay? So let's do client credentials here. Cool? I think that's it, yeah? So we have a client that is allowed to talk to API, yeah? It has a secret, and we have set up the API resource, okay? So now how do we wire that up? Basically, again, by putting them into the DI container. We still have multiple versions of that. We have an in-memory, add-in-memory API resources, where you just use the class you've just written. You could use an entity framework-based thing, or you could write up your own resource store that loads that stuff from arbitrary locations. So we do add in-memory clients as well, same thing. We have so many different customers that like to do it differently. So we have a couple of people that prefer the CI style, where when they change something, someone does a pull request internally, someone reviews it, it merges it, and then it gets redeployed. Other people like to, use databases, so that's up to you. You just wire up the right services here. Okay, so that looks like it could work. Let's have a look. Okay, so here's our host, using console logging to see what's going on. And the first endpoint you want to check is the well-known endpoint, right? That's the configuration of the token service. It's the metadata, if you like, and that is all being handled by the IdentityServer middleware, right? So we are handling the protocol endpoints, and now you can see we have a token service that is named like this. Here are the URLs of all the protocol endpoints. Here are the 2 scopes we support, API and offline access. Here's the 1 claim we support. That is all sourced by the definitions you made with your resources, okay? And the most important thing here is that's where you can get to the public key that can be used by clients or by APIs to validate the tokens that we emit, right? That's the public key that belongs to the private key that I configured in my startup. Cool? So let's see. The API should probably be restarted. Let's kill the API host so it has a chance to refresh its configuration. Yeah. Okay. Here's our API. So here's our console client. Let's run that. And here we are. Okay? So in other words, you don't have to change anything in your client applications because on the wire, it's the same protocol. We actually have a test project in our repo that has all the different combinations of running IdentityServer3 and 4, having APIs on Katana, having APIs on ASP.NET Core, and just calling them in all permutations just to make sure that they are cross-version compatible, so to speak. Yeah. So that's working fine. A couple of things about the client. Where is it? Here. So we got feedback from a couple of people So again, in version 3, we demanded that every client has a secret, right? So, as a security guy, it didn't make sense to me to start with that why shouldn't we have a secret for a client if that is supported by the spec, right? But again, after doing lots of work with different customers, it turns out there are situations where secrets don't make any sense. For example, for publicly deployed clients, right? So something that you deploy from the App Store to an iPhone, why would you need a secret there? Yeah, and I always said, like, yeah, you know what, then don't treat it as a secret. Call it secret, right? But there were internal, penetration tests and stuff, and they said, like, yeah, you are using a secret here. You shouldn't use a secret, even if it's not secret. So we forced people kind of to introduce secrets, even if they didn't need it to. So yeah, that's gone. Okay, so we removed that. So in our config here, if you want to, and if it's a so-called public client, you can say require client secret false, and then the secret is gone. Okay. Another thing we got feedback on is, especially for server-to-server style communication, is when you are requesting the token, we demanded in version 3 to pass in the APIs you want to talk to, the scopes, API 1, API 2, API 3, whatever. Yeah? Now, when you have many scopes and many clients and so on, and especially for like data center style communication, they said, like, why do we need to pass in those APIs explicitly? Yeah? Can't you just give me a token for all the APIs the client has access to? Otherwise, every time we are adding an API, we need to change the client code, we need to change the configuration, blah, blah, blah. So in other words, if I remove that now, then you will get whatever is configured in the allowed scopes list. Okay? Again, something to make it a little bit easier, especially for bigger environments. So, good. Let's go to the MVC style client. Where is that? Here's the configuration. So here's our MVC client, so let's just copy this guy as well. Copy that over here. So you see it's almost the same, right? Again, flow became allowed grant types. And there's a grant types .hybrid. Yeah? Hybrid flow means the first leg is done via the browser to get the identity token and the code, and then the client does a back-channel communication to exchange the code with the actual access token. So that's the hybrid flow. That's the recommended flow for browser-based clients if the application is server-side. We introduced something called, so what we've seen is that many people didn't use the hybrid flow in the past because they either, that's like a later chapter in the spec, and maybe they didn't read the spec until that point. But the hybrid flow is the most secure one for web applications because, as I said, you are not exchanging the actual access token via the browser, right? I mean, what's the point of you need an access token on the server to talk to an API, which is also on the server, but you are transporting the access token once across the world, down to the hacked Wi-Fi in Starbucks, and up again to your server. So we introduced this thing called allow access tokens via browser. And that defaulted to false, unfortunately, because it would have been a breaking change in free. Now this defaults to, this defaulted to true before, and now it defaults to false. So in other words, if you are trying to do implicit flow here, and you want to transport that access token via the browser, you will get an exception by default saying, hey, you are trying to send an access token via the browser, but you haven't opted into that feature because, it's dangerous, a little bit at least, yeah? So that is gone now because that's our default value. So here our redirect URIs. We still have a client secret. Here are the allowed scopes. So that's all fine. So what we now need is these guys. OpenID and profile, they are now in our new configuration system, they are identity resources, yeah, and not API resources. So let's create a method. Called getIdentityResources. GetIdentityResources. Return new. So OpenID is a standard scope from the OpenID spec, so we can just do new identity. Oh, that should be identity resource. New identity resources.openid. And the profile is a custom one. So let's do a new identity resource. Give it a name, profile. So whenever somebody asks for profile, we can return, I don't know, whatever we want. Give it a display name, profile data, and we can return, let's say, a given name and family name. Family name and location again. Okay? So that's how you define your own identity resources. And then we just wire them up in our startup class. So we say add in memory identity resources. config.getIdentityResources. Okay, so as I said, logically the scopes haven't changed, but we try to split it up into two distinct things: identity and APIs. And that is the main reason, as I said, was because that's how you model, right? So when you're drawing, you're when you're on the drawing board and draw your system, you have the APIs, right? And you have your identity, and these are two distinct things. That's why we thought it makes more sense to separate them into two distinct classes. Okay, so now we have defined getIdentityResources. We have defined the MVC client. Now we need two things. Users, obviously, and a UI. Okay, so the UI is probably the biggest thing that has changed between 3 and 4. So I said in the beginning, the reason why we wrote our own view engine and forced you guys to use it is because by the time there was no UI framework that was running outside of IIS. Right? The only thing was MVC, really, at least full-featured. Our design goal was to not be tied to IIS because we have many customers that just want to run that in an NT service, right? So yeah, so that was what we had to do, yeah? And we weren't happy with that. Now in ASP.NET Core, right, we have MVC proper, which runs outside of IIS if you want to. Well, no, it always runs outside of IIS, yeah. Or there are other alternatives soon, I'm pretty sure. Yeah? So, okay, so let's write a UI. So we're going to use MVC for that. So let's add MVC, Microsoft.ASP.NET Core.MVC 1.1.1, and we need static files. 1.1.0. So now you have a couple of options how to get your UI in here. Yeah? One very common scenario is that you started with an application that had all the login stuff built in, and you now want to write a second application and you want to share the login pages between the two by putting them into IdentityServer. So you just copy your existing login page out and put it into IdentityServer. That's one way to start. The other one is to start from scratch, obviously. The third one is you can even just use one of the default MVC templates. So if you want to get started with MVC login pages using ASP.NET Identity free, then just use that template in Visual Studio, and you can add us to that template, and it works as well. Or we have think of like a starter kit for you. Yeah. So there used to be a thing called NuGet content packages, where you just basically pulled in a NuGet and it spit out static files into your project. That's gone. That feature in NuGet, or not back again already. I don't know. It's gone right now. So what we did is we have this repo called IdentityServer4.QuickStartUI. And what this contains is just the UI parts that you need for an identity server, right? It's a login page, it's a logout page, it's a consent page. Done. Okay? So what you can do is you can just go here, download that, and put it into your project. So with this little script here, hello, we can just copy that down. So let's do this. Demos, delta demo before, source, cd source, IdentityServer4 host, right? So we can copy that in here. And this pulls down the contents of the GitHub repo and copies it into your directory. Okay? So what do we get when we do that? Well, we get an account controller, yeah, which has a login page. Here's your login page. We have a couple of services that are UI related. So the most important one is the Identity Server interaction service. So when you're writing your own UI, you probably still want to know what's going on right now in what are the details of the current authentication request, like who's the client, you know, which parameters did he send in. So that's all you get from this new service here. And basically how our logic works is the client goes to the authorized endpoint, which is handled by the middleware. And when the user is not authenticated, we just redirect to, by default, to /account/login. And that's configurable, but that's the default value. And that's where you in MVC world, you typically have your login page, right? And then it arrives here, and we give you a return URL, yeah, just like you would with cookie authentication or with, you know, in the old days with forms-based authentication. And this return URL points back to the authorized endpoint, so we can continue with the flow. And now you are in full control of, you know, you can do whatever you want, right? You can start an arbitrary complex login workflow. Maybe register the user, you know, do your two-factor, whatever. When you are done with whatever you need to do to make the login happen, yeah, you sign in the user just using the normal ASP.NET Core Authentication Manager API. You make sure that return URL hasn't been tampered with here, and then you return, and then you redirect back to us, and we continue with the protocol stuff. Okay? So we think that is the best way of doing that. Yeah, we handle the protocol stuff, you handle the UI, and you go back to us when you're done. Make sense? Because, to be fair, the UI is always the thing you will always change, right? I mean, you typically don't want to use our login pages, yeah? Okay, so that's this thing. The next thing is, where do we get users from? And we had a class in IdentityServer4 called in-memory user, yeah, and in-memory user store. And we thought it's pretty clear that this is only useful for development scenarios, yeah? But then you start getting issues on GitHub saying, how do I load my SQL Server users into your in-memory user store? And I thought, like, maybe that's not the best way of doing it. So we removed the in-memory users altogether. But then we realized for doing demos like this, it's handy to have something like that. Yeah? Then we put it into a different assembly. Then we put it into the Quick Start UI. And finally, we brought it back and now renamed it to test user. I hope that's clear now. Yeah, it's not for production, okay? So what the test user gives you, basically, is a way to just have a couple of users in your system, you can give them arbitrary claims here, you can give them a password, so you can, play around with the token service. Yeah? Okay. So how do we wire up that? You say add test users. That's what it's called, yeah? And that class is called test users.users. Okay, and again, we're just putting them into DI, so the login page can now use it. Cool. Let's run it again, and let's see if our MVC client is now working as expected. Okay, so we go to secure. Oh, I know why. So here we obviously have to, first of all, add MVC now because we're using MVC, right? So we do services.add MVC, and here we do app.use static files and app.use MVC with default root. Okay. Good. And our MVC client, secure. Okay, here's the login page. So we have Bob and Bob. Consent page. And we are back. Okay. So now I'm not sure if my API is still running. We'll see. Yeah, and that works as well. Yeah. So the only thing that's missing now from our little migration project is the external login, right? So we used to have Google logins before, and that's not there yet. So let's have a look how that worked in free. Here in our startup. So basically what you needed to do in free is you had to give us a callback method that wires up the external middleware, like Google, ADFS, Facebook, whatever. And since we are like building the pipeline, we had to inject these middlewares at the right point in the pipeline. So basically we said, here's a callback. We call that at the right point in time to wire up the middleware. Okay? So that's not needed anymore in 4. We can just pretty much copy that to our startup class, like this. It's now called Google Options, I think. Let's see how good IntelliSense is here. Come on, go green. Yeah, I think it kind of did green. So this is now called sign-in authentication scheme in ASP.NET Core, and this is gone. What we also need is a cookie middleware to store the temporary outcome of the Google authentication. So let's add that as well. Project JSON. Do we have cookies already? Yeah. No. ASP.NET Core cookie authentication. Right, so we do app.use cookie authentication, new cookie authentication options. We give this this thing a name, authentication scheme, that's called. Now, just to be able to work with our default UI, we have a constant what the name of this middleware should be, and it's called IdentityServer constants .external authentication scheme, and we want to do automatic authenticate is false, and automatic challenge is false as well. So, and then here we say sign-in scheme is now IdentityServer constants.external authentication scheme. Okay? So that's how you migrate that, and that is not even IdentityServer specific, it's just ASP.NET Core. Yeah? So now the way this works is, we have 10 more minutes, that's good. The way this works is on our account controller, you see on the login page, what we're actually doing is we're building a view model. So when we go here, you see that now we are calling on this interaction service, we call it the get authorization context method, which returns you an authorization request. So now in your UI, you have all the details that you need to know about the current authentication request. As you see the client IDs there and the display mode and blah, blah, blah. And if you want to pass custom parameters from the client to the server, we give them to you in this parameters collection. Okay, so you can pass in your custom stuff as well. And ultimately, what this is building is a view model for the login page, which looks like this, yeah? Do we allow local logins? And that's the left side of the screen with name and password, right? And if you have that, do you want to have the checkbox with the remember me checkbox, yeah? And do we have external providers? Yeah? That's how the view model looks like for the login page. And then what we can do is, you see on the ASP.NET Core Authentication Manager, there's a method called get authentication schemes. And that returns now all of the externally registered providers like Google and Facebook and Azure AD and so on. And that's how we can automatically build a view model that gives you, like, login with Google, login with whatever buttons on the screen. And if you see the actual view, it gets pretty clear how that works. So when we go to the login view, you see we have the login view model here. So if we allow local login, we render the name and password box. If we allow the remember me, we model that. And if we have external providers, then for each provider, we are rendering a little button. No? So it's not black magic, it's just ASP.NET. Cool. So let's see if that works. So the last demo, I guess, is run the server again. And run the client again. And you see now we have the Google login as well. Okay. And now I'm logged in, with Google, and my data is coming from Google now. No? So we have a little bit more time, so maybe the very last thing I want to talk about is a very common request we had with IdentityServer4 was, a scenario where you had a mixture of internal users using Active Directory and external users using a password or Google or whatsoever, yeah? And believe it or not, it was very, very hard in Katana and ASP.NET to support both Windows authentication and something else in the same host. Yeah? So our solution to that was we wrote a little mini STS, yeah, that you hosted in a different application that was set up for Windows authentication. And then the job of this mini thing was to authenticate the user using Windows and then return a token back to us so we could give you the Windows integrated authentication experience. Now, this has changed a lot, actually, in ASP.NET Core. So you know that in ASP.NET Core, you are not tied to IIS anymore. So when you are on Mac or whatever, you don't have IIS, so IIS is an optional component. But in the Windows world, Windows authentication for web applications is implemented by IIS. Okay? So there's this little thing here that they give you in the standard templates called use IIS integration. And what this does actually, I don't like that it's so much magic, but that's the way implemented is. What it does is it actually wires up middleware. Yeah, so you would think you can only wire up middleware in the configure method. No, that's wrong. There's a startup filter, something you can implement that allows you to hook into the configuration process as well, and that's what this thing is doing. And one of the things that this use IIS integration call is doing is it wires up a Windows authentication middleware. Okay, so you can now explicitly do a challenge on the Windows authentication middleware and trigger Windows authentication explicitly from within your host, even if your host is using cookies as the main authentication method. Okay, so that's pretty cool. How do we need to get that to work? You see, I'm running self-hosted now. So I have to switch to IIS for obvious reasons, right? Let's see how this is configured. So it should run on localhost 5000. So you need to enable Windows authentication here, right? And if I now run that again, I'm running in IIS now. So I have this Windows authentication middleware. And if I'm now starting my client, what I should see, I hope, I never prepped this, but let's see what happens. Yeah, here we are. Okay, and when I now click this guy, I'm logged in with my Windows account. Okay, and you know what? What actually many people do is this. On the login page, yeah, they do this. They do a check like if the IP address of the client machine is in the intranet, let's directly switch to call the external login method and pass in Windows as the provider. And then for your internal users, they get directly Windows integrated authentication. For the external users, they will get the screen with the buttons how they want to authenticate. Yeah? So yeah, we are pretty happy how this worked out because nothing of that needs to be an identity server feature anymore, right? Because ASP.NET Core has all these pretty good, actually, authentication APIs, so we don't need to reinvent the wheel here. We just give you full control how you want to interact with us. Any questions? We have 4 minutes, yeah?
So this quick start stuff is really, really good.
Yep, thank you.
If you are, like many companies are right now, going down the more JavaScript path, is there something similar?
Well, so the thing is this. Let me show you that. Where's my startup? So when you are configuring Identity Server, yeah, you can pass in an options object here, like this, and you can do authentication options. Hold on, authentication. Options. Authentication.sign login. What is it called? Authentication scheme. Oh no, interaction options it's called. User interaction.login URL. Okay? So this is basically the URL we redirect you to whenever we need to show a login page. Okay? And that could be anything, right? It's up to you. The only thing you need to do, that could point to something / hashtag, like some routing, Angular, whatever. The only thing you need to do when you are done with your login UI, you have to call a controller in the server-side application that sets the cookie, right? And when the cookie is set, you redirect back to the return URL that we give you, and that's it, right? Yeah. Any other questions? Yes?
Is it possible to suppress some of the default claims, like AMR, for example?
No, because they are actually mandatory by the protocol, right? But what you rather would do is, you would, in the client middleware, the OpenID Connect middleware has this events thing here. So you can say events equals, new OpenID Connect events. Like this. And then there's there is an on token received event, and then what you get here is on e.ticket.principal. Basically, the on token received event runs after the token has been validated, but before they hand over the control to the cookie middleware to issue the cookie. So what you can do is you can just take the principal, take the claims you want, throw away the others, and just let it through, and then you only get the claims you really care about. And you have the same option with web APIs, but in web APIs, it's not that terrible. But here you want to save space in the cookie, probably. Yeah. Yeah. So that would be that approach. Yeah. There were other questions. Some people raised their hand. No. Good. Then we are on time. Thank you. Bye bye.